What if I told you that everything you see, the stars, this planet, even you, isn't actually made of stuff at all? What if it's all just structured motion? Today, we're diving into two theories that start with that very wild idea, but they end up in two totally different fascinating places. So, let's get into it.
Just soak that in for a second. Motion is, all else becomes. That's the knockout opening line from the main paper on universal motion theory, one of the two ideas we're looking at. And really, it says it all. The big idea here is that motion isn't just something things do, it's what everything is. All right, so let's meet our two main players. In one corner, we have universal motion theory, or UMT for short. And in the other, we've got a broader idea called, simply, motion theory. Now, you should think of them less as enemies and more like, well, intellectual cousins. They both started from the same incredible idea, but they have very different game plans for how to explain the entire universe.
Now, before we get into what makes them so different, it's actually super important to understand where they agree. Because at their heart, these two theories are built on the same philosophical foundation. They're starting from the same page, and it's a pretty radical page to begin with. And this really shows you their shared DNA. First up, they both agree. Motion is the absolute base layer of reality, full stop. From that, they say time isn't some fundamental river flowing through the universe. Nope, it's just an emergent property, basically our way of measuring motion. They also throw out the idea of singularities, the infinitely dense points inside black holes. In this view, motion can't just come to a dead stop, it just changes form. And gravity? It's not a force, it's an effect of all this underlying motion. And maybe most importantly, both theories say, hey, don't just take our word for it, we're making claims that you can actually go out and test and potentially prove wrong.
So let's start with universal motion theory. A good way to think about UMT is as the specialist. It's not trying to tear down the entire structure of physics as we know it. Instead, it works right inside Einstein's general relativity, but it adds one really clever, powerful new ingredient that changes everything. And that new ingredient is a concept called curvature activation. The idea itself is actually pretty intuitive. Imagine you have a dimmer switch for gravity. Out in the vast, empty parts of space where space-time is pretty flat, the switch is basically off. But as you get near something like a black hole, where space-time gets incredibly bent, that switch starts to turn on, dialing up the effects of gravity. So how does this actually work in the math? Well, UMT lays it out in a pretty clear four-step recipe. Step 1, you measure how much space-time is bent using the standard tools from general relativity. Step 2, you take that measurement and you run it through a special mathematical function that behaves just like that S-shaped dimmer switch. Step 3, you plug this new switch right into Einstein's famous equations. And the result? Presto! The new math just flat-out prevents curvature from ever becoming infinite, which means those pesky singularities just disappear.
Now this is crucial. This isn't just a neat trick on a blackboard, because UMT actually changes the rules of gravity in extreme situations. It makes real, solid predictions that we can look for out in the universe. It says we might be able to detect faint echoes in gravitational waves after black holes merge. It predicts that light should bend in weird ways around giant cosmic voids. It even suggests that some of those mysterious fast radio bursts could be the sound of that gravity switch getting flipped on.
Okay, so that's UMT, the specialist. Now let's switch gears to motion theory. And if UMT is the specialist, then motion theory is the philosopher. It doesn't just want to add a new part to the engine, it wants to rewrite the entire instruction manual, starting with the most basic words we use to describe reality.
And this table says it all. Motion theory looks at a concept like mass and says, that's not a thing in itself, it's just a way of describing how much something resists a change in its motion. It looks at time and says, that's just a comparison of different movements. Gravity? Well, that's just the natural tendency for different patterns of motion to sync up and clump together. It's a complete reframing of our physical dictionary.
And the goal here is, well, it's breathtakingly ambitious. Motion theory isn't just trying to solve problems in cosmology. It's aiming for a grand unification of everything. The idea is to create a single framework that can describe quarks, chemical reactions, living things, maybe even social systems, all as just different patterns and scales of synchronized motion. Okay, so we have our specialist and our philosopher. Let's put them right next to each other because it's time to really nail down the single biggest difference in how they operate. It all boils down to one simple idea. Are you working from the inside or are you rebuilding from the ground up? And here it is, the key takeaway. Universal motion theory takes its big idea, that gravity switch, and it installs it inside the existing working machine of general relativity. It's like a performance upgrade. Motion theory, on the other hand, wants to toss the whole machine out and rebuild a brand new one from scratch, using only one kind of part: motion.
And because their approaches are so different, they ask to be judged on completely different things. UMT is pointing its telescopes at the sky. It's saying, judge me on this specific data, on gravitational echoes, on how light bends, on these radio bursts. It's very targeted. Motion theory, though, has a much broader scope. It says, judge me on how well I can connect everything, from the cosmic microwave background all the way down to experiments on a lab bench.
So which one is right? The laser-focused specialist with its concrete predictions, or the grand philosopher with its sweeping vision? Well, you know, the beautiful thing about science is we don't just have to sit around and argue about it. The universe itself is the lab, and the experiment to figure this out, it's already running.
But here's an interesting thought. What if these two aren't really rivals at all? It's possible to see UMT as just one very specific, very mathematical version of the bigger philosophical idea of motion theory. Maybe it's just one concrete proposal for how a universe built on motion could actually work.
And that leaves us with the really big question that scientists are going to be tackling for years to come. If this whole idea is right, that motion is truly fundamental, then which of these detailed models is going to survive when we hit it with hard data? And which ones will turn out to be, just fancy new labels for the same old mysteries we've always had? Finding the answer, well, that's what makes all of this so exciting.